It's their circumference times theta out of 360.
We're not recording.
No. So this is the arc length. But the page that we're about to do is not talking about arc length. Like, this will tell you like if this is like 10 inches or something. The page we're doing is just going to be like 80 degrees, 100 degrees, something like that. So there's kind of two different ways to look at arcs. How long are they with like a tape measure, and how long are they in relation to the rest of the circle in degrees? So a central angle is equal to its arc. That's what we just said. What about an inscribed angle? How is it related to its arc? It is half. So if, let me change colors here. If it's hitting the same arc, an inscribed angle is only going to be half. Something like 40. And if two inscribed angles have the same arc, they would have to be the same measure, right? It's another trick. And another trick we learned, if you draw a diameter, what's the measure of the semicircle? What's the arc? 180, half of the circle. So there's a lot of tricks. Anyway, these two add up to 180. These two this adds up to 180. Arcs. You guys remember how we drew, like, represented arcs? Like if you say arc AB, it just means like that. But if you say arc ACB, minor arc, major arc, you have to go a long way around, all the way like that. So for major arcs or semicircles, use 3 letters. Anything 180 or over, use 3 letters. If it's short, just use 2 letters for minor arc. Okay, number 1. So if you look at angle XWD is 58 degrees, then what would the arc that it intercepts have to be? Yes, twice as big. Yeah. So it's 58 times 2, so it's 116. So on number 2, if angle X, so arc YZ is 178. So angle X would have to be, what would we do? 178 divided by 2. Alright, and then it gets trickier. Did you cause me Dion, or did I cause you Dion? Okay. So on 3, any ideas? Right. So JL is a diameter, which means it's cutting the circle in half. So arc JK and arc KL together should add up to 180. So if we did 180 minus 108, that would give us arc JK is 72 degrees. And if arc JK is 72 degrees, what's the inscribed angle that goes, or how do we find the inscribed angle? Divide by 2. 36.
How do you find the 72?
JL is a diameter. It's cutting the circle in half. So that means there should be 180 degrees on the left side of that diameter. So we did 180 minus 108. Okay, how about number 4? No diameters on number 4. Any ideas?
Just be the 37 divided by 2 from the other side. And minus 6.
You're close. You said one thing wrong.
You do the 37 times 2, then you add 135, 74, and subtract it from 360.
Okay, yes. So what they're saying is we know arc XY.
That's going on my highlight reel.
I just imagine you doing a soccer celebration around there. Sit down, Isaac. All right. Isaac, what do you normally play in soccer?
Attacker.
Striker.
Yeah.
What do they call it, like left forward, right forward or something?
Yeah, that's if you have 2 of them.
Okay, that's all soccer I need, thanks. I'm just teasing. All right, so if angle W is 37, then arc XY is 37 times 2, so it's 74. All 3 of those arcs, there's 3 arcs in the picture, have to add up to 360. So if you do 360 minus 135 minus 74, that will give you arc WY. Is it? Did you understand number 4?
Yeah.
You did, but it was, you don't think you would have got it on your own?
No, this is the test I really struggled with, remember
Oh, yeah, I did. Okay. Number 5. Number 5 is like one we've already done. Which one is it like?
that? 3.
Number 3. So we gotta use a similar trick. If RT is a diameter, that means everything above RT should add up to 180.
So,
16 plus 17x minus 2.
Okay, so arc RS is gonna be 180 minus 116. 64. So I think it might be hard to tell with the picture because they had to like type it in, but that thing they wrote in there, the 17x minus 2, that's supposed to be in this corner over here. And what did we say this was? 64.
and then,
So we gotta figure out a relationship between these two. So it's this, half of this equals that, right? That's one way you can say it. So 17x minus 2 equals half of 64. That should do it. So if you struggled with this chapter, I would just maybe on your page of notes just put some copy some examples.
it doesn't help.
Examples?
Yeah.
Why not?
Because, I don't know, it's not the actual problem.
Well, you need to be able to understand the example. You don't understand what we just did?
Oh, yeah, I do because you're explaining it.
Okay. So if you think you need a reminder, then you need to write yourself a note. So to explain it to your future self. Be a friend to future you. Like that, Susie?
Yeah, let me see. I might actually quote that. That could be my funny quote.
You can quote it, but don't put my name under it.
Why?
It's cheesy. No, that's fine, I don't care. Okay, 7, it's kind of hard to tell what's going. Oh, I skipped number 6. Any ideas on number 6? I kind of remember this one. This, it looks more confusing than it is. Let's put it that way. If angle K is 3x plus 23, then what do we know know about QL, RQL? Is it supposed to be half that or twice that?
Twice
Twice
that.
that.
So that times 2.
So yeah, ArcQL should be twice 3x plus 23. So it's, I'll draw this, but it's kind of confusing because they drew more stuff than is actually needed. Just threw you off or something. Because we don't really need like angle M or anything. If this is 3x plus 23, if you multiply by 2, we get 6x plus 46 for this arc. And they said this is 9x minus 6, and this is 140. Any ideas where we can go from there? Well, we have all the entire circle represented by these three arcs, right?
That
One.
equals 360.
Yeah, they should add up to 360 then. So that plus that plus that. That's probably the hardest one on this worksheet. 6x plus 46 plus 9x minus 6 plus 140 equals 360. That's a lot of work. Let's see, that would be 40, 180. So, yeah. Okay. 7 looks kind of confusing, but it's angle X is 10x plus 8 and angle K is 12x minus 2. What do we know about angle X and angle K? Yeah, they are the same. Why do they have to be the same? Because they both share arc YZ. So they should both be equal to half of arc YZ. So they should be equal to each other. So 10x plus 8 equals 12x minus 2. Oh. Just do the memory. Okay. Elephant. Blowing its nose over there. Okay. Plus 2. Now, they're kind of mean to us. They said find arc YZ. So we're supposed to plug that x equals 5 back into one of those 58, but then to get the arc YZ, we'd have to do 58 times 2. Yeah, 116. Lots of tricksy ways to ask these questions. Yeah, we've established. Okay, how about number 8? Alan, I just saw your shirt. Care to explain?
It's this day at our church, it's a certain song that one of my best friends like. One of my best friends, he likes the song. And it's this, not really a kid song, but we sang it for our kids' church. And it was his birthday. And it says, dude, brother's not so sick. So one person has the dude, Ivy Bro, and he has his own music.
I thought it was just because people said bro.
I say Bro a lot.
Bro. In algebra, like last hour, it gets said about 50 times per class.
Or is he by Roman?
Because Easton's in there, Roman's in there, Lennox, there's a bunch of bros, even the girls. Easton's the worst offender. Okay, any ideas on number 8? Give up. Right. Yes, they all add up to 360. So it's kind of like number 6, but easier because they already.
I would like it if it was just algebra and not all this other
Not the
crap.
geometry. Remove the geometry part.
Yeah.
I definitely remember seeing some of these on the test. I mean, I only chose a few from each chapter, but
How many questions are on one?
it's probably like 40, 50 or something like that.
And then do we plug it back in?
Oh, yeah. For the LM mark.
The answer is 7/116.
Yeah.
Yep. All right. Number 9. I'll talk about how to set these up. And we'll move on. I want to do the stuff we haven't got to yet, the bottom stuff. So on 9, angle R should be equal to half of the arc. Or you could say, you could do angle R times 2 equals the arc. So you could do like 2 times 6x plus 14 equals 15x plus 1. That would work. Angle R time in parentheses times 2 should equal that arc up there, right?
Mr. Gervais or?
Yep. You got a cold?
Allergies.
And we plug it back in, right?
For the angle.
Okay, good. Everybody. This is 2 times 15x. So to make it equal.
I don't know.
So X equals.
Yeah, and you put, okay, so you put 9 back in for the angle R. Isaac, do you still play soccer?
No, not anymore.
Hung up the cleats?
Yeah.
Onto football kicker? Okay, I'm not sure why they put. I kind of want to skip number 10 for now, because it's the same as number 8. So I'm not really sure why they put 11 and 12 in there, because it's a repeat of 1 and 2, kind of. So on 11,
Okay.
how do we find angle B? Divide by 2. On 12, how do we find arc LN? Times 2. It's kind of easy to get those mixed up. I wish I knew a trick, but maybe you guys can think of a trick too. Or just take a good note, maybe, I guess, in this case. Can you remember that the angle is smaller than the arc? Don't know. Okay. On 13. So that angle PQR on 13 that says 58 degrees, it's technically not an inscribed angle because it's not inside the circle completely. It's got a tangent line, but it still works like an inscribed angle. Angle PQR is going to equal half of its arc QP. So if angle PQR is 58, the arc over there in the corner is 58 times 2. It's 116. And if that arc, the small arc is 116 and the big arc is 60x plus 4, how can we figure out what x is?
You add them, which equals 360.
Right, they add up to 360. Again, we kind of use that trick a lot, right?
60 is 250.
You're 60.
You get it? How about the decimal?
Did it? And we might have written it wrong. 58 times 2 is 116. 116. Did you? No, it comes out right.
What? I did it wrong.
These add up to 120. If you subtract 120, you get 240. 240.
Oh, I subtracted that.
240 divided by 60. 4.
Wait, so how did you do it? I did it differently, but I wrote the same answer.
Yeah, x is 4. What did you
I
do?
just did the angle to the arc like we can do with everything else.
Hmm?
The angle to the arc.
Oh, you did the backside angle. Yeah, that's fine.
I don't understand the reason.
We found the little arc using the angle 58 degrees is 116, and then 116 plus the big arc equals 360.
We don't have to do it again, right?
No, it just says find x. Yeah, it's a little bit easier on that one. So 14 is kind of like number 9. 2 times the angle equals the arc. So 2 parentheses 13x minus 3 equals 25x plus 2.
think I'm median,
Good.
but I'll probably slip out like that in this class.
That's why you take good notes.
I would say,
Oh, I remember this.
I remember I just don't remember.
Okay, yeah, 15 is what I really wanted to get to, because
Don't you?
I wish they would have started with some not algebra problems.
Isn't it like, how do you subtract something?
Yeah, that's
To make it inside here?
part of it, yes. Let's start with 18, and then let's go back to 15. So 18 is different than the other three because the chords are meeting inside the circle. So on 18, what you do is it's the arc plus the arc divided by 2 equals the angle in the middle there. So it's 15x minus 10 plus 50
Divided by 2 equals 8x plus 15.
Yeah, 8x plus 15. And if I put one of these on the test, which I pretty good chance I did, I might not have put the x's on there. It might just be numbers, but I'm not sure. I'll have to look at it. Okay, what can we do algebraically here?
You add the negative 10 to 50.
Yeah, you can do that. Negative 10 plus 50 is just 40. Now what?
Divide by 2. I don't know.
If you divide by 2, you'd have to divide both of these by 2. How can we get rid of a divide by 2?
Times 2.
Times 2. So if we multiply this side times 2, that just goes away. And then this side gets a times 2, but that would be a distributive property. Well, I'm just going to go ahead and do it. I think there's a really, I really don't remember, but I think there's a really good chance there's a problem like 18 and a really good chance there's a problem like 15 on there, like one of each. And maybe a couple of the other ones too. Ew. Is that Mr. Totino? He's blowing his nose. Sounds like an elephant.
Do we have to turn this in?
No. Cool, there you go. I'll give you guys some points. Throw on some points at the end of all this for participating, being such lovely
Can you
participants.
scroll back up just a little bit?
So when we have x's on both sides, you want to get them off of one side, right? So you subtract 15x. Alright, and yeah, we are supposed to plug x back in to find arc RS, but it's just, it'll just be 5 times 10 minus, 15 times 10, 150 minus 10 is 140. That's, yeah. Number 15, that's what I really want to get to. Okay, I could tell some of you vaguely, kinda almost partly remembered. Let me label this 12x plus 3. So we've got two arcs here and an angle. These lines that go through the circle are called secants. Doesn't really mean that much, but it's just lines through the circle. 3x plus 12. So what's the relationship between the two arcs and the angle between it? No. It's kind of like number 18, but
Would be 12x plus 3 minus 35 equals 2.
you're getting warm.
Plus,
Just like on
divide by 2.
divide by 2. Okay, so it's kind of like the last algebra thing we did. What can we do? Could combine these two things. It'd be 12x minus 42. But what do we do about that 2? Well, last time we multiplied both sides by 2. This time it would be kind of easy to divide by 2 though. Just divide both of those by 2. You can always divide by 2, but sometimes you get fractions and decimals or whatever. So you could do it that way. Probably not the final answer, is it? And if they make you plug it in to find arc MP, you just do 12 times 11, 132 plus 3 is 135. All right. Do we do one more of those? Yeah, let's do one more. Which one do we want to do? 16 or 17? All right. 16, that's fine. 16 is kind of a trick question. It's definitely a trick question. So yeah, actually I kind of don't know why they did that. What do we know about those two arcs in the picture? Well, they would have to add up to 360. Kind of feel like I don't know, they kind of screwed that one up. You don't even need that angle out there, so I'm not sure what they were thinking on that one. That's okay. Let's just skip that one. All right. Five, very good chance I put that on the test. I don't remember really, but probably because I thought, oh, that's easy. We'll give them a couple easy ones. 6 might be on there too. It's not as easy, but still possible. I did put a circle question on the test. but I can't remember if it was like 15 or 16. It's one of those. Anyways, number 5. Well, the trick that we learned was if two chords, like chord WY and SU, are the same distance from the center, they have to be the same length. So that was kind of the trick. Also, radii that are perpendicular to a chord are going to cut it in half, bisect it. So, if WY is 34, how could we find WZ? Divide by 2. It looks like it's half, and it is half. So don't overthink it. Well, I mean, hard problems do exist, but not all of them are hard problems. Well, if you're thinking, is it as easy as it seems, I might just go with it, because if you're not sure. Okay, so similarly on B, we're supposed to find SU. If PZ and PV are 5, that's telling us the chords are the same distance from the center. If PZ and PV are both the same thing. If WY is 20, then how long is SU? 20. Ding, ding, ding. Throw those two at you, that'd be nice maybe. Number 6, not so nice. But that means we probably need to talk about it. So, finding XZ. Let's see. We got SU is 24. Let's see, where's that at? And WY is 24. Got that. And PT is 15. Yeah, I might need to draw this. Take me forever, but I think we're okay. What time we get out of 35? 40? 35? Shoot.
We're almost done. We can make it.
Quickly. How long is this? 15. Okay, so that tells me the radius is 15 long, right? If that thing's 15. And what else it telling me? SU is 24. All right, if this is 24, how long is it from there to there? 12. What? Yeah, so this is really tricky. If the radius is 15, I drew in an extra line. Did you guys see me do that? This is not in the picture. But it is also a radius, right? And so that means it has to be 15. And this can help me find that. This was naughty of me to put this one on. So it's 12 squared plus x squared equals 15 squared. Right? Pythagorean theorem, yes. Like, I think if I fast forward, I get x is 9. So if x is 9, how long is, this is what they're actually asking for, how long is y? Well, if the whole thing is a radius, it's 15, just like this one, so it's 15 minus 9 is 6. Okay, 15. So I definitely remember seeing a circle question, but I forgot which kind of circle question. It was more like 15 or 16. 16, the center of the circle for 15, the center of the circle is at -3, +1. So you just do the opposite of what it says. And the radius is going to be the square root of 4, which is 2. So on your graph, you just go to like -3, 1, put the center, and then you go like out 2 in all directions to help you draw a circle. So it looks kind of like that, except for better. -3, 2 is the center, and the radius is 2. We're doing okay. You can relax a little bit. Oh, I said 2. It was 1. Nobody checked me on that. It's -3, 1. Well, I drew it right, though. -3, 1, radius is 2. Okay. For 16, it's kind of the opposite. They're giving you the center and the radius, and you're supposed to write the equation. So, notice how I did the opposite, right? So if it says -5 for the x-coordinate, then you do x plus 5 squared. Plus, and then the y-coordinate is 8, so it's y minus 8 squared. And the radius is 4, so you're supposed to put 4 squared